Welcome back to Jackson Square. Today our topic is going to be fraction operations, addition, and subtraction. How can I solve problems with fractional numbers? So we want to start off by remembering that a fraction has a numerator and a denominator. Numerator is the number on the top, denominator is the number on the bottom. Adding and subtracting fractions should be easy, but it takes a little bit of work to get to our answer. First of all, adding and subtracting fractions is not like multiplying and dividing. When adding and subtracting fractions, you have to find a common denominator. How do you do that? It's called the least common multiple. So a common denominator is called the least common multiple or the LCM. So we're used to saying the GCF, greatest common factor. We have the least common multiple. Then you add or subtract the numerators, and then the denominators stay the same. Stays the same. Okay? So just think about it like this. You put in all this work to find a common denominator. Why are you going to change it? It stays the same. So you don't do anything to the denominator. Only the numerators are going to be added or subtracted. Okay? So apples to oranges, you want to have oranges to oranges. Okay? You want to add the oranges or subtract the oranges. You can't have an apple and an orange and just say, I got fruit. We want the same type of fruit. So you have to have a common denominator. Simplify your answer if needed. We always want to simplify. So I wanted to go back and talk about what is a multiple. We've talked about products, we've talked about factors, but we haven't really talked about a multiple. Multiples are super easy. They're easier than factors because multiples is just skip counting, okay? So that's just skip counting. You did it in elementary school. 2, 4, 6, 8. Who do we appreciate? Miss Jackson. Hey, Miss Jackson. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 10, 20, 30, 40, 50, 60, 70. Skip counting. So multiples is just having that number and skip counting. That is how you get your multiples. So when we are finding our least common multiple, we are just going to list them out. For GCF, we do the prime factorization, we do the factor tree, but for LCM, we can just list them out because we mostly know how to skip count, so it's pretty easy, right? You can find LCM using factor trees. If you're interested in knowing how to do that, I can do another video for you or teach you that method in class. There is a way, it's the same factor tree, you just use a different set of numbers when you're circling groups. So let's look at our first problem. We have 3 8s plus 5 6. The first thing you must ask yourself, are the denominators alike? Your answer should be no. Okay? So, are the denominators alike? The answer should be no. So 8 and 6, they're not alike. So we're going to create lists of their multiples. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. Whenever you see the first one, the first number they share, the first number they have alike in this list of multiples, that's the LCM. Least common multiple. That's the smallest multiple that they have in common. So the LCM for 6 and 8 is 24. The LCM is 24. So now that I know the LCM is 24, I have to go back and say, do I need to rewrite one fraction or both fractions? I want both of them to have a denominator of 24. Is 8 24? No. Is 6 24? No. So I need to rewrite both of them to have new denominators of 24. Okay? So how do we do that? By multiplying. This is where knowing those multiplication facts comes in handy. What times 8 will give me 24? 3. Whatever I multiply the denominator by, I'm going to multiply the numerator by the same thing. I have to get a new number here. That number is not going to stay 3. That would not be balanced. We have to multiply the bottom and the top by the same number. So that would be 9. I want you guys to just remember a key word. A key word for math is balance. There's always steps and there's always balance. If I do something to one side, I do it to the other. If I do something to the top, I'm going to do it to the bottom. You always have to keep it balanced, keep it proportional and reasonable, okay? What would I multiply times 6 to get 24? 4. Whatever I multiply the denominator by, I have to multiply the numerator by the same thing. Please do not forget to multiply the numerator because then your fractions are not going to be proportional. They're not going to be balanced. So this would give me 20. Now I have 2 new fractions that I can work with because they both have denominators of 24. So now my problem, I'm going to rewrite it, is 9 24ths plus 20 24ths. So my directions say find a common denominator, then add or subtract the numerator. So now they have a common denominator. I can add 9 plus 20 and get 29 24ths. The denominator stays the same. This stayed the same. I just wrote it on the bottom, okay? Simplify your answer. Well, what kind of fraction is this? This is an improper fraction. So because it's improper, we want to make it a mixed number. How do we make it a mixed number? I hear the people saying Tebow. Yes, yes, yes. Tebow, Tebow, Tebow. You're going to divide top in, bottom out. How many times can 24 go into 29? Just one. Just one time. Multiply, subtract. I have a remainder of 5. Remember, when we're writing our mixed number, we want quotient, remainder over divisor. Okay, divisor. So my quotient is 1. My remainder, didn't write it. My remainder is 5. And my divisor, the number outside of the house, is 24. So the final answer is 1 5/24. How was it? Tough? A lot of work? Math is a lot of work, but if you enjoy math, it's enjoyable. I enjoy doing all the work. It's exciting, invigorating. So let's do another one, actually. So let's jump down to example 3. We'll come back to example 2 later. Example 3, 9/10 minus 3/5. First thing, do they have a common denominator? Nah, they don't. They don't have a common denominator. So I need to list out some multiples. 10 and 5. 10, 20, 30, 40, 5, 10, 15, 20. So these are pretty simple. I'm stopping because I know I've already seen it, but I just wanted to list out some. The least common denominator, or the LCM, least common multiple, for 10 and 5 is 10. Okay? So I could have stopped at the second one. I just wanted to write a little more. Now, go back to our problem. Do I need to rewrite one or both fractions? I want the denominator to be 10. That denominator is already 10. I don't need to do anything. This one, however, is not 10. So I need to make a new equivalent fraction with a denominator of 10. So how would this look? 9/10 minus 3/5. Okay? 9/10. It's already 10. I'm just going to bring that straight over. It's already 10. 3/5. I need to multiply something to get the 5 to be a 10. What do I multiply times 5 to get 10? Yeah, 2, right? Okay. Yeah, times 2. Whatever I multiply the denominator by, I also do the same to the numerator. 3 times 2 is 6. We want to keep balanced. Keep it balanced. So here's my new problem with my new equivalent fraction. And now I can subtract these. 9/10 minus 6/10. Awesome sauce. So 9 minus 6. All I have to do is subtract the numerators. 9 minus 6 is 3. And my 10 stays the same. I did a lot of work to get that 10. I'm keeping it. 3/10. It can't be simplified. We're done. That's it. It's over. Okay? It is over. Okay. I'm looking at the last one from my notes. This problem, we want to change the order to 7/11 minus 2/3. Because if we leave it this way, we will have a negative answer, and we don't want a negative answer. Okay? So what I'm going to do is I'm going to tell you to pause and practice with a number 2 and number 4. Practice these two problems. Come back and see if you got them right. Welcome back. Let's get to adding these fractions. So 2/5 and 1/7. I hope you noticed right off the bat that they did not have common denominators. So hopefully you listed out your factors for 5 and 7, and you found that they had a LCM of 35. And then you realize I have to rewrite both of these because they neither have 35. So 2/5 is equal to something over 35, and 1/7 is equal to something over 35. Now we got to figure out what we multiply by to get 35. 5 times 7 is 35. So 2 times 7 will give me 14. 7 times 5 is 35. So 1 times 5 will give me 5. These are my new equivalent fractions that I'm going to work with. So we will have 14/35 plus 5/35. Remember that my denominator stays the same. So I just need to add 14 plus 5. I will get 19. It can't be simplified. We're done. So hopefully you had 19/35. Questions? Concerns? Errors? Let me know. Let's look here. 7/11 minus 2/3. 2/3. 7/11 minus 2/3. Common denominator? Nah. So you need to list out your factors. Maybe you were able to look at it and off the top of your head, you were like, I think I know the LCM. And hopefully you did. And you wrote that the LCM was 33. If you got 33 for your LCM, you are righter than right. That is correct. So then you say, rewrite both, rewrite one, rewrite both. We have to rewrite both of these fractions. So 7/11 equals something over 33, and 2/3 equals something over 33. What can I multiply times 11 to get 33? 3. 7 times 3 is 21. And, excuse me, 3 times 11 is 33. And 2 times 11 is 22. And as I'm writing this, I'm realizing I should have left the problem in the order it was in, because now it's backwards and I can't subtract 22 from 21. So 22 minus 33, I'm just going to switch it. Don't you switch any problems. I can do this. 22 minus 21 is going to be 1/33. I don't know. I go back and forth with this problem like every year. I'm always like, it's not right. It's wrong. I don't know if I updated it. Maybe I updated it and I don't realize it. I don't know. I have this issue with this problem like every year. So it's not you. It's me. I need to change this worksheet, but I still haven't. So hopefully you got those right and you had no problems, no concerns, but we're not done yet. There's a back. All right, so now we have to look at mixed numbers and possibly borrowing when we have mixed numbers. So this is exciting. Yes, it is. So we have 2 and 5/6 and 1 and 3/4. They realized that these were not common denominators. They listed out their factors for 6 and 4. They found that the LCM was 12. Okay, so then they brought the whole numbers over. So the 2 came over, the 1 came over. The only part that they rewrote was the fractional piece. Okay, what times 6 will give me 12? Times 2. What times 2 times 5 will give me 10? So the fractional piece is rewritten, okay? What times 4 will give me 12? 3. 3 times 3 will give me 9. Only the fractional piece. The whole number piece was carried just straight over, okay? So once they did that, they added the numerators. They got 19/12, and they got 3. 2 plus 1 is 3. 3 and 19/12. Well, the fractional part is improper. So I think it's our duty to do something. We can't leave it like that. So how would you do that? That's where our buddy Tebow comes in. So to make this improper fraction into a mixed number, you're going to say top in, bottom out. How many times will 12 go to 19? 1 time. I'm subtracting. I will end up with a remainder of 7. Pay attention. It gets weird around here. A little bit weird, okay? So then I'm going to have 1 and 7/12. 1 and 7/12 is this thing, right? But since I have a 1, I have a whole number part, I'm going to add that to 3. I'm going to add those together, and they're going to become 4 and then 7/12. So that's where the 4 came from. They added the 1 plus the 3, and then the 7/12. The 1 and 7/12 took the place of this. So let me write that out. So what does that look like? It looks like this plus this. So that's how they end up with 4 and 7/12, because 1 and 7/12 took the place of the 19/12. So you add the two whole numbers together and the fractional part stays the same. So that's pretty cool, right? When you have an improper and then you can add it and make that. So that's pretty cool. I'm going to demonstrate another one too for you, or would you like to try it by yourself? I'm going to let you try it for yourself. So pause here try it. And if you get stuck, just start the video back up and I'll walk you through it. You got stuck already? You're back so soon. It's okay. Let's jump right in. So this time we are subtracting 5 1/6 minus 2 2/3. First thing I want to do is I want to make these improper, or you can just change the fractional piece. So it's two ways you could do it. I'll show you both ways. So 5 1/6 would become 6 times 5 is 30. 30 plus 1 is 31. So this becomes 31/6. Okay? 2 2/3 is 3 times 2, which is 6. 6 plus 2 is 8. So this becomes 8/3. So then again, you notice that 6 and 3 don't have a least common multiple. But if you listed out your factors, or you said 3, 6, 9, 3, 6, 9, you would know that the LCM is 6. So then I say, do I need to rewrite one or both fractions? Well, this one already has a 6, so I don't need to rewrite it. I just need to rewrite this one with a denominator of 6. What times 3 is going to give me 6? Hopefully you said 2. And this will give me 16/6. So now my problem is 31. I'm trying to figure out what to write it. 31/6 minus 16/6 equals. So again, remember my denominator stays the same. I did a little bit of work. Why change it? I'm going to subtract 16 from 31. You can do some side work to get that. You should get 15/6. Well, this is a lovely, lovely improper fraction. We want to make it a mixed number. You would do T-bow. I'm not going to show you guys because I know right now you're like, I'm over T-bow. I got it. 6 will go into 15. Hopefully you said 2 times. So that would give us 12. And then we would have 3 left over. And our denominator stays the same. 2 3 6. What? Oh, I hear some people saying simplify. So we need to simplify this. This can be simplified by 3. So you would get 2 1/2. Final answer, 2 1/2. So again, let's zoom it out. Looks like a lot of work, but not really. Pretty easy. I wrote a lot of stuff on the paper. Some of you may not have written all the stuff. I just want to make sure that you have something to follow. But not that much work. Pretty easy. I got the answer quickly. I think you might have too. I hope you got the right answer. Let's look at the other way you could have solved this problem. So let me draw a little divider here. And this purple is not really helping because it looks just like the blue. So what if I did not want to make it improper? What if I just wanted to keep it mixed? If you just wanted to keep it mixed, you could do that. That's your world. So I have 5 1/6 and 2 2/3. I found my LCM is 6. I'm going to do the same thing. So this one would just come straight over, 5 1/6. And here, my 2 would come over, but I need a new denominator of 6. Okay, so just like the one above, when I told you we only are concerned about the fractional piece, I'm only concerned about the fractional piece. So the 2 is going to stay there. The 5 is going to stay there. I'm concerned about the fractional piece. So now that I know the LCM is 6, I only have to rewrite one of them. What times 3? We know 2. 2 times 2 will give me 4. So I can now, I'm going to do this all in this one space. I hope it does not confuse you. Well, let me put a little barrier here. I'm going to subtract this problem because it's a subtraction problem. 1 minus 4 I can't subtract 4 from 1. So, what do I do? You're going to borrow, just like you would borrow any other problem. I'm going to borrow from the 5. When you borrow from the 5, it's not like the other place value. When you borrow, you're borrowing one whole, okay? So when I borrow, I'm going to be borrowing a whole piece, not a fractional piece, a whole piece. So this 5 will become a 4. And instead of adding 10 here, it's not going to become 10/6. You're borrowing one whole, which is the same as 6/6, right? Yeah, okay. So now you can add that together. So 6 plus 1, because this is a fraction in a fraction problem. They have the same denominators, right? This is an addition problem in a subtraction problem. Like, isn't that cool? Okay. So they have the same denominators. This becomes 7/6. So now this is 4 and 7/6. Can I subtract 4 from 7? Yes. I can subtract 4 from 7. I'm going to get 3. 6. And then 4 minus 2 is 2. What? Are these the same? I got the same answer. Doing it this way and doing it the other way. You get the same answer. So whatever one is comfortable for you. Again, you still have to simplify. You will end up with 2 and a half. So that's 2 options or 2 ways you could do the same problem. I think that it's fairly cool. Right. You will get some more problems to practice with addition and subtraction of fractions. I hope that you enjoyed the simple versions, and I hope you enjoyed the challenge versions, and I hope that you know how to simplify fractions, and you got some practice in, and you got to flex your little math muscles and your skills. Good luck with your practice.